Thank you for the terrific introduction. I'll try and live up to it. So I just have a few objectives for this talk. I know we're a little bit pressed for time and it might be a little rushed, but I'll try and get through the materials. One, I want to provide an overview of data-driven challenges in healthcare. Because if you think about it, healthcare is very, very much data-driven, from making a diagnosis to understanding patient's prognosis to actually determining which treatment to use. Second is to provide an overview of AI medicine landscape in Canada and then focus on the Toronto environment. And then to provide an overview of the Applied AI Health Program at Unity Health Toronto, where I'm from. So the title actually is real, that we're actually saving lives with ML. You may have kind of seen all the titles in the newspapers these days. When do we admit Canada's healthcare system just isn't working? Wait times for medical procedures at 20-year high in Canada. Next, nearly 75% of Ontario doctors experiencing burnout. 90% of nurses considering leaving the profession in the next year. The system's broken, right? And we're really, really struggling. But then you see things like this, how AI is helping shorten patient wait times. And you start to think, maybe there's some hope. Maybe there's a role that ML and AI can play. So what's happening in Canada? We are in an incredible position to play a leadership role in the world around AI and ML. We have tons of data assets. Here's some examples of organizations. ICS has provincial data, administrative databases, about 16 million people, followed up for about 20 years, which is incredible. We have Genome Canada that drives genomics efforts in terms of data. Alberta Health Services, which has basically consolidated a lot of health data into one entity, which is fantastic, and other provinces should take their lead. Institutions like SickKids that have set up pretty impressive AI programs. We also have technical expertise. We have three world-leading AI institutes, Vector in Toronto, Amy in Alberta, Mila in Montreal. We have new organizations like T-CAIREM that I'm going to tell you about that are trying to really infuse collaboration to get people to work together. And of course, we have lots of groups now starting to translate, which is really exciting. In the private sector, we have groups like Blue Dot, Signal One, Deep Genomics. I'm going to tell you a little bit about my institution in the public sector that's really developing and deploying these solutions into clinical practice. The University of Toronto environment and the Toronto environment in general is very unique. And I say that after talking to a lot of colleagues around the world. Why are we unique? To do AI and ML, in my opinion, my perspective, if we talk about AI in medicine, it's about technical skills, but it's also about context. And we have both. So if you look at U of T, we have one of the top statistics department in the world. Computer science, among the top in the world. Engineering, among the top in the world. Education, among the top 5 in the world. Medicine, among the top 5 in the world. All of this is coming together at U of T and the Toronto environment. That makes us incredibly powerful. So other colleagues, when I hear them talk about, I am having trouble finding a good data scientist. We just recently had a posting for a junior data scientist. We had almost 300 applications. We don't have that problem here. We have lots of talent and lots of good people here. We also have data institutions like ICS. We have AI institutes that do cutting-edge research like the Vector Institute. But the other nice thing is we have a network of hospitals. So the Toronto Academic Health Sciences Network, or TASN, is a group that actually meets regularly. So about 14 academic hospitals, another 6 or 7 community hospitals. There's over 20 hospitals that meet regularly. So it's this really nice ecosystem and environment. Here's some of the examples of the types of things that are going on in Toronto. At the Toronto General Hospital, there are researchers who developed an algorithm that predicts 1 in 5 year survival with the likely causes of death among patients who undergo lung transplant. Why is that important? These patients die, right? And if you can understand when they're going to die, you can actually inform them, but also the causes of death, so you can actually start treating them appropriately. So if you know that this patient's going to have trouble with cardiovascular disease, you're going to be more aggressive in cardiovascular disease management. If we look at breast cancer, one of the issues we have with breast cancer is there's first-line chemotherapy for patients who require it, right? Sometimes we get it wrong, and the patient doesn't respond. Weeks and weeks go by. You try another. It doesn't work. Weeks and weeks go by. You've just spent 3 months trying to figure out what the right treatment strategy is. Well, there are researchers at Sunnybrook that have an algorithm that predicts response to chemotherapy with 96% accuracy. Promising. There's a pretty interesting surgeon here at the Toronto General Hospital at UHN, University Health Network, who's using laparoscopic guided surgery, cholecystectomy, that uses AI to identify areas where you should operate and where you shouldn't. I don't think I can actually move it to play the video on here, but there's a video here that actually goes through time, and it actually highlights green areas where you can cut and red areas where you shouldn't cut. And it's constantly changing according to how you're operating. And if you cut in the red area, you're going to have a pretty high likelihood of major bile duct injury versus in the green areas, you'll have a low likelihood. So it actually kind of guides you of where to cut and where not to cut. It's in prototype stage right now. Again, very, very promising. One problem here is we tend not to work together. So, the hospitals will do their own thing, but there's nobody really bringing them together saying, we're really strong, but we can be so much stronger if we work together. So we had a very generous donation from the Temerty family, over $20 million, specifically focused on an AI center that would bring a lot of people together so we can advance AI in medicine. So what we've done is we've created the Temerty Centre for Artificial Intelligence Research and Education in Medicine. This center is open to anybody in the academic space. So if you're a student or faculty, I'd encourage you to go to our website, tcairem.utoronto.ca. Anyone can become a member. Why would you want to become a member? Well, we have three themes. Education. We have pretty impressive speaker series. So we have people from all sorts of places. Stanford, Harvard, Oxford, Cambridge. We've had lots of people give really inspiring talks around this space of AI in medicine. We have a learner series. So if you're a student, typically what we do is we pick two students to present, a medical student and a non-medical student. So we actually get different perspectives. So these are trainees who meet regularly from computer science, engineering, statistics, medicine, all learning from each other because this is a team sport. It's very multidisciplinary and we have to accept that. Studentships. Last year, we gave out 20 summer studentships to work with University of Toronto faculty in the space of AI in medicine. This year, we're giving 30. And of course, there's lots of workshops and training opportunities as well. We also offer innovation grants. This year, I think we've offered over $700,000 in grants. Lots of really impressive ideas in the AI in medicine space. Again, this is all done through our center. And of course, there's infrastructure. One of the big issues is you can't do AI without data. And what we find is, especially with poor professors who want to teach, they'll say, well, download this data set, do this analysis on your laptop. Your laptop isn't made for compute. It's not great. So we've created something called the Health Data Nexus, and we're just in the process of launching it now, where it's on Google Cloud. And we're putting in anywhere from $3 to $5 million for its development and its sustainability over the next 3 to 5 years, where it's actually a place where we house data that are relevant to healthcare. So for example, we have a data set of about 14,000 patients, patient-level de-identified data that almost anyone can use. And we're going to continue to grow these data assets in the Health Data Nexus, making it, that will make it one of the best in the world. It's modeled after MIT's PhysioNet platform, and it's already leapfrogged their platform, which is really exciting. All of this can't really be effective without community. So we have lots of community engagement activities. So for example, we have something called the Collaboration Hub. Very simple, easy concept. It's like a Kijiji for AI in medicine. So anyone can fill out a form. So for example, I'm a neurologist at Sunnybrook Hospital. I have access to 4,000 head CTs, and I have no idea what a 3D convolutional neural network is, but I know it's neat. Is there somebody who wants to work with me on this? And so we post it. We have over 1,000 members in our community right now. And what happens then is a computer scientist can say, I have funding, I have grad students, I don't have your data or clinical expertise, why don't we work together? So it's fairly new. We've had about a dozen of these come up, and we've already matched half a dozen of these, and we'll continue to match people to bring together people who would normally not work together. And of course, there's Hive Hubs. If somebody says, I want to do much more work in AI and irritable bowel disease, we've actually literally have somebody say that. We said, all right, why don't you take the leadership role and you create an interest group, and you can actually lead it. All we require is 5 people who say they're interested as well. and tell us what the parameters are. We'll provide the platform. Tell us that you want 50 people. You want to meet monthly. You'll chair them. Tell us what your objectives are for the next 6 months. We'll set everything up for you, and you can actually lead a group of people in the area of AI and bowel disease or whatever you like. Again, this is just about to launch soon, so we'll see more activity here, I hope, in the future that will actually bring people together. What we've recently done is we've expanded nationally. So we now have 23 universities that are part of our network across the country and healthcare organizations as well, so over 60 organizations involved, making us, I think it's safe to say, the largest AI and medicine network in the world, which again, I think is very exciting. We also are spreading internationally as well. So we just signed a memorandum of understanding with Technion University in Israel. We're also exploring a couple of other memorandum of understandings of other institutions from around the world as well. Again, for anyone who's interested, the website is here. I'd encourage you to join. We're also part of this thing called the Alliance of Centers for Artificial Intelligence in Medicine, or ACAIM. This group meets regularly. And it's over 50 centers that focus on AI in medicine all around the world. And all the way from NYU Langone, Mayo Clinic, there's places in China, Japan, Australia. We all come together and meet and we talk about what we're doing. Just March of this year, we're very new, T-CAIREM is very new, but we were actually named Institution of the Year. So I think it just speaks to how Toronto has such incredible talent, incredible potential in this space. But here's what I struggle with. A lot of this is really good academic, cute research, right? How do you bring it to reality? It's not easy, right? It's really hard to push things into practice. There's a systematic review that was done recently. This is a study that actually looked at over 400 publications during the pandemic. And each of these studies was showing, hey, here's a solution for AI and COVID. And what the authors did was they actually looked at every single one of those studies and they said, how many of these will actually be deployed and can help our patients? Zero. Because a lot of times research doesn't translate. So I'm going to tell you a little bit about my hospital, the one that I come from. I'm based at the St. Michael's site, but we're St. Michael's, St. Joseph's in Providence in Toronto. Just very quick stats. We're a tertiary care teaching hospital in downtown Toronto. We take care of the sick and poor. So we're basically Toronto's inner city hospital. We're one of 2 adult trauma centers in the greater Toronto area. So gunshot wounds, stabbings, those sorts of things, they come to us or Sunnybrook. It's one of the 2. We have about 500 beds, over 6,000 staff, over 900 physicians, over 1,600 nurses. Approximate annual patient volumes, we have about 80,000 emergency department visits a year, over 500,000 ambulatory visits, and over 25,000 inpatient visits. Why am I telling you these numbers? If you multiply this by 15, because that's how much historical data we have, that's a lot of data to work with. We have a research institute, and we're fully affiliated with U of T. So what have we done? We've actually set up an AI program. This is what a lot of hospitals do. It's cute. Right? You set up, you hire data scientists, you say, we're going to solve all the problems. But what ends up happening is the data scientist says, your hospital servers can't handle my ML algorithms. I need deep learning servers. I need compute capacity. Hospital servers don't do that. Okay. What else do you need? Python. I need R. I need PyTorch. I need TensorFlow. What the heck are those? Because we don't talk like that in healthcare. How do you set up an environment where data scientists are going to be enabled and empowered to be able to do the work that they do? So we actually spent 3 years creating a data environment that's made for AI. We hired data scientists, but we didn't do it just randomly. Right? A lot of people will say, let's just get a computer scientist and it'll be fine. No, it won't be fine. Because you have to hire people who understand the areas that you're trying to tackle. So what areas are you trying to tackle? It's not coming from the data scientists. It's coming from our doctors who are seeing our patients, our nurses, our physiotherapists, our pharmacists, our medical decision makers. They know what the problems are. So when we asked them, what do you struggle with? It became very clear it's not just about computer science. It's about operations research engineering with simulation optimization. It's about traditional statistics. So we actually hired 3 streams of data scientists: statisticians, computer scientists, and operations research engineers. Because the magic happens when you actually combine the 2. You can imagine if I tell one of my computer scientists, hey, so there's this multiple sclerosis patient, just developed a new T2 lesion, here's a head CT, or the MRI, they're going to have no idea what I'm talking about. But the neurologist does, right? The nurse does. They understand the problems. So I'm not going to get my data scientists to lead the issues. They're going to lead the issues. Our computer scientists and our data scientists will actually help support and build solutions to the problems they tell us they want solved. So it has to be a team sport and a combined approach. How we're structured, it's actually very simple. I'm the vice president. I actually have 3 core teams with an additional team that we've just set up. Our first team is our data integration and governance team. It has nothing to do with ML. It has everything to do with data engineering and pipelines, because we have to fix that problem first, right? We have a lot of data, but it's really messy. So we have ETL developers, data engineers, data modelers, architects, all in our data integration and governance group. They grab data from source systems in real time. That's the other trick. Can you get it in real time? They clean it, scrub it, and send it to our second group. Because our data scientists, I don't want them spending 80% of their time cleaning data. That's not their job. They spend their time developing the models. And that's our advanced analytics team, where we have our computer scientists, our operations research engineers, and our statisticians. We're awful at developing product, right? I'm never going to get somebody who does neural networks to develop a software solution for me. That's not what they do. So we have a product development team. It's headed up by an artist. He's actually a musician. I don't know if he had a midlife crisis, but he went and did a Master of Science in Applied Computing and Machine Learning. But the lens that he comes from is, I don't really care so much about the code around the algorithm. I care about human AI interaction. I care about design. So he heads up a team of people who focus on human factors, on software development. Because I can tell you, things will fail if you don't understand change management, people, psychology, behavior. That's what they focus on. What does a product look like and how is it going to help you? These 3 teams work together. In fact, when we get a project idea, the first team that's on it is not the data integration governance team. It's not the advanced analytics team. It's the product development team. Because we have to understand if this is going to be a viable product. And then we work backwards to how you get the data and build the models. We've been getting a lot of pressure on commercialization, and I'll tell you why in just a bit. So we're just in the process of developing a bit more of a comprehensive commercialization strategy. And the last team that I'll mention is, being a researcher myself, we are awful at project management. Right? We can't project manage to save our lives. So we have a dedicated team of project managers who focus on lean methods, timelines, milestones, deliverables, and keep us honest. This is just a chart of the types of projects we do. We've deployed over 40 of these. So as we speak right now, at our hospital, we have over 40 solutions that are running in production. And we continue to develop more. Here's an example of one of them. And again, our model is very simple. Our end users lead, and they have to commit to working with us throughout the duration of the entire project. So if you're a clinician who has a great idea and you can't commit to staying with us for 6 months or so, however long it takes to develop a solution, we're not going to work with you. You have to make that commitment. You have to lead. So this is based on an actual patient from our hospital that was about maybe 4 or 5 years ago. 73-year-old retired banker came in for an inflamed gallbladder or cholecystitis. This is a fairly common condition, actually. Fairly, you work it up, you manage it, and you send them home. Pretty standard. So they had the workup done. The physician was called that evening at 6:30 p.m. because the patient had shortness of breath. So the physician ordered checks, x-rays, and labs. The vital signs were checked twice overnight, midnight and 6 a.m. The physician was called the next morning because the patient had a sudden drop in blood pressure. Unfortunately, he didn't do so well and he died that day. And the family, they were distraught. We would never have left his bedside. So when we asked our internists, they said, 1 in 12 internal medicine patients will die in the hospital. And we asked, what can be done? So they said, well, there's lots that could have been done. We could have increased monitoring. We could have looked for signs of sepsis or a bad infection and thought about antibiotics. We could have called the critical care response team and just say, you know what, you guys are intensivists, just be aware of this patient. Know that if he comes to you, you'll know how to manage them. We could have called palliative care. Because if we knew this patient was going to die and we couldn't do anything about it, at least he could die a comfortable, dignified death. And we could have communicated with the family. We could have done this much earlier, but we didn't because we didn't know. The reality is among those patients who go to the ICU or die, over half of them are unexpected. We didn't know. So their challenge was, can we predict who's going to die or go to the ICU so we can intervene earlier? And we said, sure. So we've had this up and running for over 2 years now. We have an early warning system where the way it works is every hour on the hour, it monitors all of our general internal medicine patients. So it grabs typically over 100 features. And it actually then categorizes our patients as low, medium, and high risk. As soon as our patient reaches a high-risk threshold, it's automated to page the medical team. And our medical team, our protocol is they have to see that patient within the next 2 hours. And they have care pathways. Here's what we're going to look at, here's what we're going to assess, and here's how we're going to change care if we need to change it. So we deployed this in October of 2020, and we started seeing these texts come in from our faculty, our attending physicians. The resident on call overnight received a high-risk alert around 11 p.m. She went and reviewed the chart and saw the patient as per the recommended protocol. He was relatively stable, so maybe the machine learning algorithm got it wrong. But approximately 2 hours later, she received a call from the nurse that the patient was decompensating. As she already knew the patient, she was able to quickly assess at the bedside and get the ICU team involved. The patient went to the ICU but did not thankfully have a respiratory arrest, which was certainly a risk if the intervention had not been done as quickly. The resident feels that the AI program made a big impact. That's fine. Those are quotes, right? These are actual mortality rates from our hospital. So when everyone goes up and says we're going to save lives, I genuinely mean it. I think we are going to save lives here. This was before algorithm deployment. When the pandemic started, January to March of 2020 is when we first started seeing COVID patients come into our hospital. If we compare our mortality rate among our high-risk patients to the previous 4 years, we saw a 35% increase in mortality. April to June, we saw many more COVID patients. We saw a 70% increase in mortality. July to September, 37% increase in mortality. Because it was a good summer, we didn't have as many COVID patients. That's when we said, that's enough. So we deployed the algorithm. It started running in October of 2020. And despite seeing many more COVID patients in our hospital, we saw decreases in mortality. So we do feel like we're saving lives. Lots of considerations here. You can imagine deployment, performance metrics, evaluation, so many things to be thinking about. Little things like if you alarm me as a doctor, as a busy physician or a busy nurse, 10 to 20 times a day and you get it wrong a lot of times, I'm not going to listen to it. I'm just going to ignore it. So there are other early warning systems out there. They alarm 10 to 20 times a day. Ours alarms once or twice a day. It's all about human factors. To get their attention, you have to mean it. And how do you actually tweak the algorithm to maximize performance in certain areas? It's all based on what clinicians want to see. Privacy and confidentiality. As data scientists, we don't want de-identified data. If Mr. Jones is going to die, we need to know it's Mr. Jones. So there has to be access to identifiable data. You can imagine all sorts of risks and liability. If the physician said to us, if this algorithm says this patient's going to die and I don't do anything and this patient dies, do I get sued? We had to get legal consults and all that sort of stuff in there as well. Bias and equity. We're able to understand if our algorithm performs just as well among young versus old, among sick versus not so sick, among males versus females. We don't have good data on race. We don't have good data on gender or socioeconomic status. We don't know if there's bias there. And some ethicists would say, well, it's not ethical. You have to do that homework. And I would say, we can do that homework. Should I pull out the algorithm and let those people die? And maybe we'll find some bias issues and that may be small. Or do we keep it running and help it save lives? So there's all sorts of these sorts of discussions that happen in practice. Other algorithms, just to give you an example, the types of things we do. Nurse staffing. Staffing is really difficult because we have a really big shortage. How do you actually optimize your nurse staffing so you're efficient and you don't waste money? We developed an optimization algorithm a couple of years ago, deployed it in 2 hospitals, and I didn't do the calculations with our nursing lead who did it. The estimated annual cost reduction was about $1 million a year, something very simple that was developed within a month. Another algorithm, people bleeding in their brains. We actually come in our emergency department, we actually see patients who have head trauma. The time it takes for a diagnosis from a radiologist is typically about 3 to 4 hours, and that's in a level 1 trauma center. You can imagine in other hospitals, they're sitting there for hours and hours and hours, bleeding actively in their brain. So what we have at our hospital is this algorithm that listens for the head CT. As soon as the head CT is done, it grabs it and it's able to identify if there's a bleed, where it's located, and subtype. It does this in under a minute. And what it does is it then color codes the patient in purple, moves it right to the top of the radiologist's queue, so the radiologist looks at it now rather than 3 hours from now. Because radiologists don't know, do I look at this or do I look at all these other scans that I have? We've noticed over a 70% reduction in turnaround time for radiology diagnosis, which means better care for patients. Just to summarize how we've approached it, we have an AI lab where we've built in the infrastructure. That's great. That's where a lot of people stop. It's not where you stop. The living lab is really where we've really pushed. We have the most progressive data governance strategy or framework, I think, in the country, where we've enabled access to data to people who need it, but are able to balance privacy and security. The other thing we've really focused on is the thing that nobody talks about, machine learning operations, data engineering, pipelines, that sort of stuff. It is messy. It's not glamorous. We spent a lot of time on that because you need it. And of course, we actually, in the early days, we're giving away our code to other hospitals. We're saying, we want you to really deploy this as well. Here's the code. And the other hospitals would say, we don't know Python. So we actually told them, give us some of your data, we'll run it for you, and we'll give you the output. We have no idea what to do with this output. We can't do this to support other hospitals. It's just not practical. So what we ended up doing was saying we need to go to private sector. So in April of this year, we launched a group called Signal One. It's a startup. And they're going to be taking our solutions and deploying it to other hospitals in a responsible manner. And because of this, we're actually going to be pushing more of a commercialization strategy where we have an AI accelerator and have more and more private sector companies join us in our desire to bring these technologies so we can have better care for all of us. Thank you.
Thank you. That was pretty impressive. I would like you to touch on the AI governance. You mentioned about the Living Lab. And what were the components of the AI governance?
Yeah, there's, gosh, now you're going to make me feel embarrassed because I don't know all the bubbles, but we've got several pillars. And some of the pillars that are really important are things like privacy. So who gets access to what? And then, of course, there's all sorts of things around data quality in terms of driving quality in our data. And then there's risk. So it's all a balance around how good or bad our data are, who gets access to it and what they use it for, and how do we minimize risk, not only in the data that we have, but how we use it. So what we've been able to do, for example, if you go to other places, a researcher will say, I want to do this ML project. And then you have to go to ethics approval. That takes months. And then you get de-identified data and maybe not everything you need. And then you create a model and you have no mechanism to deploy it. Where we differ through our data governance strategies, we've actually enabled our data science team, and we've signed all sorts of documents, so it's all under the framework, to have access to identifiable data in real time. And what that enables us to do is to actually understand all the messiness of the data and to be able to generate algorithms and be able to show that this patient had a high risk so we can actually know who that patient is. The other thing we don't need to do is go through ethics approval. Because what we've done is we do it anyway, but we really work under the quality improvement framework where you don't need ethics approval. But we've done it anyway because we also want to publish. But the way we've done it has had an umbrella approval for a whole bunch of projects within that umbrella. And that enables us to move much more rapidly. So all of this goes under our data governance framework that enables the right people to have right access to the right data at the right time with minimal risk and maximizing privacy. Does that help? Yeah. Yeah, absolutely. And it actually took about 1.5 years. We actually had to call in an external legal firm to help because we didn't have the right expertise in-house. Fantastic. Oh, it's fantastic. Thank you.
Hi. Thank you. Great talk. That was really interesting. I was just curious from, I realize T-CAIREM is within academic center, but is there are there mechanisms to work with commercial entities? Like, have you thought about that? How does that work?
We're actually going through that as we speak. We have an advisory committee who has been very keen on us engaging private sector, commercial entities. So we're actually coming up with a strategy around how do we actually engage private sector, because we think there's incredible value there. Yeah. So give us maybe summer to fall of next year. Great.
Hello, thank you for the talk.
Thank you.
My question is about your experience taking this type of approach to other hospitals. How I think each hospital is different, and some of them, the administration might be more reluctant to adopt AI, or even in your own experience, how difficult was it, and how do you think were the most important aspects that you will recommend to others?
Yeah, I think translating this to other hospitals was extremely challenging. One, it's an issue around culture and trust. It has nothing to do with the ML. It's about how this sector still uses fax machines, right, on a daily basis and can't get their head around a lot of these modern. It's not that we don't want it. The other issue is we're just so busy with other things. How do you focus on this when you have wait times that are just ridiculous and patients who just need better care overall? And the other thing is cost. Hospitals don't have money. And so how do you actually then say, well, you know, we have a solution that will help you, but it's going to cost you money. You automatically get roadblocks. So what we find is that the best way to do it is get the clinicians engaged and build an ROI, a return on investment, for every single thing that we do. Once we actually have a clear return on investment and can show that this has potential to really improve the care that you give or the outcomes that you'll see, it becomes a little bit of an easier discussion. Then we move on to the technical side of things. And what we find is the technical side, hospitals, we're just really, really struggling on the technical side. Many of us don't have modern electronic patient records. Our data are a mess, tons of data engineering issues. And then you get into privacy, where privacy officers, many of them, quite frankly, may not know the legislation as well as is needed for this sort of work. And so the automatic answer is no, you can't have access to data. So really having a dedicated effort to say, this is going to give you value, your clinicians want this, this is going to save you money, or it's going to improve quality of care. And there are no legislation or legal barriers to be able to, for us to do this. It takes a bit of time and understanding and education. Once we have those discussions, I think it becomes a lot easier. But this is why we couldn't do it ourselves, and we needed to engage a company like Signal One to be able to have that time and energy and dedication to be able to drive it to other hospitals. It's hard.
First of all, is it on? Hello, check. Can you hear me?
Yeah.
First of all, very impressive presentation.
Thank you.
Really good. I'm an immigrant. I'll talk about my pain point. I came here because of two reasons: health and education. Education is sorted out. Healthcare let me down because the kith and kin of my almost my friends, when they encounter anything with the health system right now, is undergoing a lot of waiting time, both on the triaging and also on the subsequent follow-up for the treatments or the surgeries. I'm talking about pre-COVID. I'm not talking about now. Yeah. I know that. But can we do something about that?
Yeah, it's a great question. I like being in healthcare because the bar, and if I know this is being recorded, and I'm happy to say it, the bar is pretty low. Right? We have so many challenges and struggles in healthcare. We don't have the discipline of a lot of other sectors. And it's largely because of, you know, I can make all the excuses till I'm blue in the face. We have lots of demand, lots of patients, poor funding from governments. Just, it's really challenging. And the government has a hard time too, because how much money are they going to pour in? Because a good part of their budget already goes into healthcare. So there's challenges everywhere. But what I struggle with is how can we make things better within the resources that we have? And that's where I look to ML, to AI, to technology to be able to help us. What's happened in the past, though, is we've been burned quite a bit. We've had a lot of technology solutions that have cost us money with very little return on investment. What we need are examples like this. If we can actually show more examples that say a solution that was developed in less than a month, low cost, and is saving you $1 million a year because of staffing optimization, that's easy to sell. But you need these proof points here. If you can have solutions that show that we're saving lives and it's not going to cost you too much and a company could do it for you, but with a tangible return, that's going to help. I think more and more of these validated solutions, I want to see more and more hospitals doing this sort of work so we actually have more proof points to convince other hospitals that there's going to be a return. Because I don't think the solution is going to be solved with more people because we're struggling with getting nurses and doctors and such. There's shortages. I don't think that we're going to have an infusion of magic dollars that's going to come in and fix everything. I think it's going to be creative solutions like this that are going to move the needle. So unfortunately, I don't have a great answer for you in terms of how we can fix our healthcare system, but I think these sorts of things are going to play a major role in the next 10 to 20 years. Please. Actually, it's funny. My father-in-law is in the hospital right now, actually, and on his floor, he's being monitored by one of our algorithms, so it gives me more comfort.
Thanks so much, everyone.
Thank you.